All right. Are you ready to dive into one of the most fundamental tools we have for understanding knowledge, belief, and evidence? We're tackling Bayes' theorem today.
Sounds daunting, maybe, but I
Yeah.
think you'll find it fascinating. It's got some really far-reaching implications,
Okay, I'm ready. Let's do it.
especially for a philosopher like you.
Oh, okay, cool. So what is Bayes' theorem really saying? I know it's got something to do with probabilities, but can we break it down a little?
Of course, in essence, it's a way of calculating conditional probabilities. So basically, it's telling us the probability of something being true, given that we already know something else is true. So like if you have a hypothesis, an idea about the world, and you observe some evidence, Bayes' theorem helps you figure out how likely that hypothesis is to be true, given that you've observed that evidence.
Okay, I'm starting to get it, I think.
Yeah,
But I know there's a formula involved, and formulas aren't really my forte.
sure.
Can we unpack that a bit?
Of course. So the formula might look a little intimidating at first, but it's really quite elegant when you break it down. So first, we have what we want to figure out. The probability of our hypothesis, let's call it H, being true given the evidence we've observed, E. And we write that as P, parenthesis, H, vertical line, E, close parenthesis.
So P-H-E.
Yes.
Okay, so that's like our updated belief in the hypothesis after we consider the evidence.
Exactly. Now, to calculate that, we need a few other ingredients. First, we've got pH, which represents our prior probability of the hypothesis being true before we even consider the new evidence.
Okay, so that's our initial hunch about the hypothesis,
Yes.
based on whatever we knew before.
Exactly, precisely. Next, we have P, parenthesis, E, vertical line, H, close parenthesis, which is the likelihood of observing the evidence if the hypothesis is true. In other words, if our hypothesis is correct, how likely is it that we would see this particular evidence?
Okay, so it's not just about whether the evidence exists, but whether it's the kind of evidence we'd expect to see if the hypothesis was true.
Yeah, exactly. You're getting it. And finally, we have PE, which is the probability of observing the evidence, regardless of whether the hypothesis is true or not. So think of this as like the baseline chance of seeing that evidence in any scenario.
Okay, so we've got our prior belief in the hypothesis, the likelihood of the evidence given the hypothesis, and the baseline probability of the evidence. So how do all those fit together in the formula?
Yeah, so here's where it gets really neat. Bayes' theorem tells us that to get our updated probability, that PHE that we talked about, we multiply our prior probability PH by the likelihood of the evidence given the hypothesis, the PEH, and then we divide that whole thing by the baseline probability of the evidence, the PE.
Wow, okay, so it's like we're weighing our prior belief against the strength of the new evidence, with the baseline probability acting as a sort of like normalizing factor.
Yeah, that's a great way to think about it. And what's so fascinating is that this like really simple formula can be applied to so many different situations, from evaluating scientific theories to making everyday decisions.
Wow. Yeah, I can already see how this could be super helpful in so many areas. But before we go too far, I think it would be good to ground this with like a concrete example.
Absolutely. Like, use a classic example that's often cited in these discussions of Bayes' theorem in philosophy. Imagine we randomly choose an American alive on January 1st, 2000. We'll call them J. Doe. Our hypothesis, H, is that J. Doe died during the year 2000. The evidence, E, is that J. Doe was a senior citizen, so 75 years or older.
Okay, so we're trying to figure out how likely it is that J. Doe died in 2000, given that we know they were a senior citizen.
Yeah.
Okay, so, I mean, it seems obvious that the probability would be higher for a senior citizen than, like, just any random person. But now we can actually calculate that difference.
Exactly. And to do that, we need some statistics. So according to the CDC, about 2.4 million Americans died in 2000 out of about 275 million.
Okay.
So a prior probability of J. Doe dying, that PH, is roughly 0.00873.
Okay, so a very small chance to begin with.
Yeah. Now, out of roughly 16.6 million senior citizens in 2000, about 1.36 million died. So the probability of being a senior citizen and dying in that year, which we can write as P, parenthesis, H and E, close parenthesis, is about 0.00495. And the probability of being a senior citizen, that PE, is 16.6 million divided by 275 million, or about 0.06036.
Okay, so we've got all the pieces of the puzzle. So what does Bayes' theorem tell us when we put all these numbers in?
It tells us that the probability of J. Doe dying in 2000, given that they were a senior citizen, that PHE is about 0.082. We get that by multiplying the pH, which is 0.00873, by the PEH, which we can calculate by dividing the pH and E, 0.002495, by the PE, 0.000873.
Wow. Okay, so knowing the Jada was a senior citizen significantly increases the probability of them having died in 2000. It's really fascinating to see how the math actually bears out what we might kind of intuitively expect, but I'm guessing this is just the sort of tip of the iceberg when it comes to the philosophical implications of all this, right?
Oh, you're absolutely right. This gives us a taste of how Bayes' theorem works in practice, but the real meat for a philosopher lies in what this tells us about how we form beliefs, evaluate evidence, and grapple with uncertainty.
Right. Okay, I'm ready for that. Let's dig in.
Okay.
Okay, my mind is already buzzing with questions. Like, if we think about Bayes' theorem as this model for how we update our beliefs, what does that tell us about, like, the nature of knowledge itself? Is it all just, like, a matter of probabilities and degrees of belief?
Yeah, that's a great question, and it really gets at the heart of what makes Bayes' theorem so fascinating for philosophers. One of the key implications here is that it lends support to a subjectivist view of knowledge.
Can you say more about that? I mean, I'm familiar with different schools of thought in epistemology, but I haven't really delved too deeply into subjectivism.
Sure. So subjectivists argue that our beliefs can be represented as these degrees of probability and that those probabilities are subjective in nature. They reflect our individual perspectives, experiences, and the information we have available to us at any given time.
So instead of thinking about knowledge as this thing that's like absolute and objective, it becomes more about how confident we are in our beliefs based on the evidence we've seen.
Yeah, exactly. And Bayes' theorem gives us this framework for how those degrees of belief should change as we encounter new evidence. It's like a mathematical model for like rational belief revision.
That makes me think of that quote by David Hume, who said, "Reason is and ought only to be the slave of the passions." It seems like Bayes' theorem is almost acknowledging that our beliefs are always going to be influenced by our prior experiences and assumptions, but it's offering us a way to, like, systematize those influences and make sure we're updating our beliefs in a way that's, like, consistent with the evidence.
That's a great connection. Hume was wrestling with these very ideas like centuries ago. And Bayes' theorem gives us a way to kind of formalize some of his insights. It shows us that our prior beliefs aren't something to be ignored or dismissed, but rather something to be explicitly accounted for in our reasoning process.
So it's not about trying to achieve some kind of purely objective view of the world, but rather being, like, transparent about our starting points and how they influence our interpretations.
Exactly. And that leads to another important concept in Bayesian reasoning, the idea of incremental confirmation.
I've heard that term before, but I'm not totally sure I, like, grasp the full meaning.
Yeah, so incremental confirmation is this idea that evidence doesn't really prove or disprove hypotheses outright, but rather strengthens or weakens our confidence in them. It's like building a case, like brick by brick. Each piece of evidence kind of adds to or subtracts from the overall weight of our belief.
So instead of looking for some, like, smoking gun that definitively proves our hypothesis, it's more about accumulating evidence over time and kind of adjusting our confidence accordingly.
Exactly. And Bayes' theorem really beautifully captures this process. It shows how our prior belief, combined with the strength of that new evidence, determines our posterior belief, like our updated level of confidence in the hypothesis.
I can see how this would have, like, a really profound impact on the way we approach scientific inquiry. If it's not about seeking absolute proof or disproof, but rather about continuously refining our understanding based on the weight of the evidence, that suggests a much more dynamic and nuanced view of scientific progress.
Yeah, you're right. And it also highlights the importance of being open to revising our beliefs as new evidence emerges. Even our most deeply held beliefs should be subject to scrutiny and reevaluation in light of new information.
It's kind of a humbling thought, but also kind of a liberating one, too. It means that knowledge isn't this static thing, but something that's constantly evolving as we learn more about the world.
Exactly. And Bayes' theorem gives us this framework for kind of navigating that process of ongoing learning and discovery. But of course, it's not without its, critics and points of contention. One of the most interesting debates around Bayes' theorem is on the role of prior beliefs and this idea of objectivity.
Yeah, you mentioned earlier that subjectivists see prior beliefs as this kind of inherent part of the knowledge process. But I imagine there are people who would argue against that, who would say that, like, true knowledge should be based on objective evidence, independent of our subjective biases.
You're absolutely right. There's a school of thought called likelihoodism that challenges this idea of incorporating prior beliefs into how we evaluate evidence.
Okay, tell me more about this likelihoodism perspective. It seems like a pretty radical departure from the Bayesian framework.
It is, in a way. So, likelihoodists argue that the only objective measure of evidential support is something called the likelihood ratio. And the likelihood ratio tells us how much more likely the evidence is if the hypothesis is true compared to if it's false.
So instead of factoring in our prior beliefs about the hypothesis, we should just focus on how well the evidence itself supports the hypothesis.
Exactly. Likelihoodists argue that bringing in prior probabilities, it introduces subjectivity and bias. And they believe that the evidence should speak for itself and that the likelihood ratio captures that in this purely objective way.
Yeah, I can see the appeal of that. It does seem like a way to strive for a more impartial and evidence-based approach to knowledge. But I also wonder if it's really possible to completely divorce our judgments from our prior experiences and assumptions.
That's the crux of the debate. It's a
Huh.
question that philosophers have been grappling with for centuries. Can we ever truly achieve objectivity, or are our judgments always going to be kind of colored by our subjective perspectives?
It seems like Bayes' theorem itself, even with its emphasis on prior beliefs, is pushing us toward this more nuanced understanding of objectivity. It's not about pretending that our biases don't exist, but rather about acknowledging them and incorporating them into our reasoning process.
Yeah, that's a really insightful point. Bayes' theorem doesn't solve the objectivity problem, but it does make us more aware of the role that subjectivity plays in how we form knowledge. And it offers us this way to kind of manage that subjectivity by being transparent about our prior beliefs and how they influence our interpretations of the evidence.
Yeah, I'm starting to think that this debate between Bayesian reasoning and likelihoodism isn't really about which approach is right or wrong, but rather about highlighting these different aspects of the relationship between evidence, belief, and knowledge.
I think that's right. Both perspectives offer valuable insights, and ultimately, it's up to each individual to decide how much weight they want to give to prior beliefs versus purely objective likelihood ratios.
This is making me wonder, are there any other ways that Bayes' theorem has been kind of applied or adapted within philosophy? You mentioned earlier it had implications for scientific methodology.
Absolutely. There are a number of really fascinating variations and interpretations of Bayes' theorem that have emerged over the years. For instance, there's the probability ratio rule, which focuses on how much the probability of a hypothesis changes after we observe some evidence.
So it's like a measure of how much our confidence in the hypothesis goes up or down.
Yeah, exactly. And it turns out that this change in probability, which is represented by what's called the relevance quotient, is symmetrical. It's equal to the degree to which the hypothesis predicts the evidence divided by the baseline probability of the evidence.
So the more surprising the evidence is on its own, the more it can shift our beliefs.
You got it. And then there's the odds ratio rule, which takes a slightly different approach. So instead of probabilities, it uses this concept of odds, like the odds of a horse winning a race. And the odds ratio rule tells us how the odds of a hypothesis change after we observe some evidence.
Okay, I'm sensing a pattern here. It seems like likelihood is this kind of key concept in all of these variations.
Yeah. You're absolutely right, and for good reason. The likelihood ratio, which measures how much more likely the evidence is if the hypothesis is true compared to if it's false, is a really fundamental concept in Bayesian reasoning. There's even something called the Bayes factor, which compares the likelihood ratios for two different hypotheses.
So it's like a head-to-head comparison of how well each hypothesis explains the evidence.
Exactly. Now, these different formulations of Bayes' theorem, they might seem a little technical, but they all kind of point to the same underlying principle.
Yeah.
We update our beliefs based on how well different hypotheses predict the evidence we observe.
Yeah, it's really amazing how one simple equation can be expressed in so many ways, and each way kind of reveals a different facet of the problem.
Yeah, and for a philosopher like you, these variations can be super valuable for analyzing arguments and evaluating evidence. They give us this really rigorous framework for thinking about how we justify our beliefs.
This deep dive is really making me rethink how I evaluate evidence and form beliefs in general. But I'm curious, besides likelihoodism, are there any other kind of significant challenges or critiques of Bayesian epistemology?
Yeah, there are definitely ongoing debates and areas of exploration within Bayesian epistemology. One interesting area to consider is the question of how we apply Bayes' theorem in these real-world situations where we don't always have these neat and tidy probabilities to work with.
That's a great point. In our, JADO example, we had these concrete statistics from the CDC, but what about situations where the evidence is more ambiguous or subjective? How do we assign probabilities to things like historical events or philosophical concepts?
Yeah, that's a challenge that Bayesian epistemologists are still grappling with. Some argue that we can use these subjective probabilities, which reflect our degrees of belief based on the available evidence and our own interpretations. Others suggest that we can develop these kind of more sophisticated methods for quantifying uncertainty and incorporating that into our Bayesian calculations.
Yeah. It seems like there's a lot of room for creativity and interpretation in how we apply Bayes' theorem to these more complex situations.
Absolutely, and that's what makes it such a fertile ground for philosophical inquiry. Bayes' theorem gives us this framework, but it doesn't dictate all the answers. It invites us to engage with the complexities of knowledge and belief and to kind of develop our own approaches to applying its principles.
Speaking of complexity, there's another aspect of Bayes' theorem that I've been wondering about. Earlier, we were talking about how it models the process of learning from experience. Can you say more about how Bayes' theorem helps us understand how we update our beliefs as we encounter new information?
Yeah, that's a great question, and it gets at the heart of how Bayes' theorem can be used to model the kind of dynamics of belief revision. Subjectivists who see probabilities as representing these degrees of belief, they often view learning as this process of updating those probabilities based on new experiences.
So, as we go through life, our beliefs are kind of constantly being refined and reshaped by the information we're taking in.
Exactly. And there are a couple of key ways that this can happen. One is through what's called simple conditioning, which is what happens when we become absolutely certain of something. So for example, if you see a ball drop, you become certain that gravity exists. And in that case, our belief is completely updated to reflect this new certainty.
It's like a light switch being flipped. We go from uncertainty to this absolute knowledge in an instant.
Perfect analogy. But of course, most of our learning experiences aren't quite that, clear cut. More often, we encounter evidence that strengthens or weakens our belief without really giving us absolute certainty. That's where Jeffrey conditioning comes in.
Okay, I'm intrigued. How is Jeffrey conditioning different from simple conditioning?
So, Jeffrey conditioning is this more general way of updating beliefs when we're dealing with uncertain evidence. So, instead of requiring this absolute certainty, it takes into account the degree to which the new evidence changes our belief in a proposition. It's kind of adjusting the dial on our beliefs rather than flipping a switch.
So instead of jumping from 0 to 100% certainty, we might move from 60% to 80% confidence in a belief.
Exactly. And both simple conditioning and Jeffrey conditioning can be seen as these ways of kind of rationally updating our beliefs based on new evidence. And as you might have guessed, Bayes' theorem plays a key role in understanding these processes.
It seems like Bayes' theorem is almost like this blueprint for the rational mind. Even when we're not consciously thinking about probabilities and likelihood ratios, our minds are essentially doing these Bayesian calculations as we navigate the world and learn from our experiences.
That's the kind of fascinating implication. While we humans might not always be perfectly rational, Bayes' theorem provides this model for how a perfectly rational agent would update their beliefs. And even if we don't always live up to that kind of ideal, it gives us a framework for understanding how learning should work, in this ideal world.
This is really making me question this nature of objectivity. If our beliefs are always being shaped by our prior experiences and assumptions, even in this Bayesian framework, can we ever really claim to be objective in our judgments?
Yeah, that's a really profound question, and I don't think there's an easy answer. Bayes' theorem doesn't offer us this definitive solution to the problem of objectivity, but it does give us a tool for understanding how these subjective elements interact with objective evidence to shape our kind of understanding of the world.
It seems like the more we delve into Bayes' theorem, the more questions it raises. It's like a gateway to this whole new way of thinking about knowledge and belief.
And that's the beauty of it. Bayes' theorem is this powerful tool for analyzing and refining our understanding of the world, but is also constantly reminding us of the, complexities and nuances involved in forming rational beliefs.
Wow, it feels like we've been down a real rabbit hole today with this deep dive into Bayes' theorem. I mean, we've explored the math behind it, the implications for how we update our beliefs, and even its role in these big philosophical debates about objectivity and the nature of knowledge itself.
Yeah, it's been quite a journey, and I think it's safe to say that Bayes' theorem, for such a seemingly simple idea, has a surprising amount of depth and complexity.
Yeah, for sure. But before we wrap up today, I want to connect this back to our listener, the philosopher. What are some of the key takeaways that they should be kind of mulling over after this deep dive?
Well, I think one of the most important takeaways is that Bayes' theorem gives us this really powerful framework for understanding how we, as like rational agents, should update our beliefs when we get new evidence. It highlights how our prior beliefs interact with the strength of that evidence and the likelihood of seeing that evidence, given different hypotheses.
Yeah, it's almost like Bayes' theorem gives us this recipe for rational belief revision. It tells us what ingredients to consider and how to combine them to come to a more informed, and nuanced understanding of the world.
Exactly. And while we as humans might not always be perfectly rational in our everyday lives, Bayes' theorem gives us a valuable guide for, moving toward greater rationality in our thinking and our decision making.
I'm also struck by how Bayes' theorem challenges us to think about the nature of objectivity and the role of, our own subjective views in shaping our beliefs. It seems like it's not about trying to get rid of subjectivity altogether, but about acknowledging it, being upfront about it and managing it in a way that lets us make better, more reasoned judgments.
Yeah, that's so important. Bayes' theorem doesn't solve the problem of subjectivity, but it makes us more aware of how our prior experiences and assumptions color how we see the world. And by making those influences clear, we can have, more productive conversations about the evidence and what it all means.
This has been a truly mind-bending exploration, and I'm sure our listener has a lot to think about. But before we go, is there like one final thought-provoking question we can leave them with?
Here's one that I think gets at the heart of the philosophical side of things. If Bayes' theorem is supposed to be this like guide to rational belief revision, does that mean we should be constantly updating our beliefs all the time? Where does intuition fit in? And is it even possible to completely escape the influence of our prior assumptions?
Whoa, that's a lot to unpack. It makes you wonder if there's like a limit to how rational we can really be, given that we're always working with, incomplete information and our own biases.
Right. Bayes' theorem shows us the path towards rational belief formation, but it also shows us just how complex and challenging that journey really is.
I think our listener, the philosopher, has a lot to think about after today's deep dive. It's clear that Bayes' theorem is more than just some formula. It's a powerful tool for exploring the very foundations of knowledge and belief.
Absolutely, and its impact goes way beyond philosophy, influencing fields like statistics, science, and even AI.
Well, we've only scratched the surface of Bayesian reasoning today, but there's so much more to discover. This is really just the beginning for anyone who's curious about how we learn, how we reason, and how we make sense of the world.
I agree. So, to our listener, we encourage you to keep digging into the world of Bayesian reasoning. You might be surprised at the insights it can offer, no matter what philosophical questions you're wrestling with.
And on that note, we'll wrap up our deep dive into Bayes' theorem for today. We hope you've enjoyed it and come away with a new appreciation for this powerful and really thought-provoking concept. Until next time, keep those minds curious and those beliefs evolving.